Our welcome badge looked fine on day one, but marketers now want a Halloween skin. Legal spotted a typo in the license URL, and analytics could use a rarity field. NFTs promise permanence, yet audiences tolerate well-logged upgrades. CryptoPunks added IPFS links years after mint. The key is transparency. Holders must verify that an upgrade is authorized and see every previous version. On SUI, we compare each badge with an immutable metadata object, plus a mutable pointer that stores only the CID or HTTP URL. Upgrades push a new immutable blob on-chain, bump a version counter, and emit an event. Wallets fetch the latest pointer but can still rewind history, satisfying purists and marketers alike. The curator already owns listing cap. We'll mint an extra meta cap so marketing and marketplace roles stay separate. Only meta cap can push a new metadata blob. Each blob stores content hash plus URL. Wallet fetches URL, computes SHA-256, compares to on-chain hash, and shows a red tampered banner if mismatched. Even if an attacker seizes the web server hosting images, the hash mismatch exposes the fraud. All versions live forever because each update stores a metadata via an immutable object, and the badge's mutable pointer simply flips to the new object's ID. Querying history is trivial. Follow event logs or walk pointers in reverse order. Metadata pointer lives inside each badge, so transferring the badge auto-transfers the pointer. Because pointers mutate, they need key plus store. Each concrete metadata version is its own key plus store resource, never mutated, enabling cryptographic provenance. Version starts at 1. Upgrades, increment. Metacap is minted once at initial collection launch and can be split or delegated. Events provide lightweight sync for off-chain galleries. The new mint initial entry replaces previous badge mint logic. We first create an immutable badge meta v1 object containing the IPFS CID and a 32-byte SHA-256 of the raw JSON metadata. Then we mint a mutable metadata pointer referencing this meta object and set version to 1. The badge now bundles the pointer. Finally, we mint a single meta cap to the caller, likely the curator address. Front-end fetches badge dereferences pointer.currentMeta to get metadata. Because badge meta v1 is immutable, even an admin can't rewrite CID or hash after the fact. Upgrading requires 3 things: a mutable reference to the badge, only owner can grant, the meta cap, and the new CID plus hash. We mint another immutable metadata object, bump the pointer's version, and emit an event. Because the pointer lives inside the badge resource, updating it mutates badge storage but not the underlying history of metadata blobs, which remain frozen. If someone sells the badge after upgrade, the buyer inherits the fresh metadata automatically. Wallets maintain a local cache keyed by SAA256. If the HTTP fetch returns a mismatched file, they flag tampering. Trust but verify. Wallet hits IPFS gateway, hashes the JSON, compares 256-bit digest to on-chain hash. If they differ, maybe the gateway was hijacked. Show a red banner, metadata file tampered. Display a V2 chip so users know the art evolved. Click reveals history. Each meta object's CID, timestamp, and event digest. On event subscription, the UI auto-refreshes. Collectors can nostalgia toggle back to version 1 art. Marketplaces default to latest. To avoid whiplash from daily art flips, we enforce a cooldown here, 48 epochs, 24 hours. The curator wallet must pace updates. If they go rogue, the DAO pulls their metacap via a multi-sig transfer and hands it to a trusted community artist or permanently burns it, freezing metadata at last honest version. Balance between dynamism and stability is encoded in move, visible to everyone.